Let's understand the problem first. What we need to find here. Here we need to find the consecutive number of stock prices before any element which are less than equal to that price. Like for 75, how many stock prices are lesser than equal to 75 and which are consecutive just before 75? Like 60 is less than equal to 75, 70 is less than equal to 75, and 60 is less than equal to 75. Do 80 is less than equal to 75? No. So how many consecutive stock prices are less than equal to 75? 3. These are 1, 2, 3, and this is the fourth one, means it would include itself also. So this is 4 this. So let's find this for all these elements. Okay, so here if we see before 100, is there any element? So that's why only 1 itself is less than equal to 100. Now if we watch from 80, we watch previous elements, 100 is not less than equal to 80, so itself would be less than equal to 80. Here 1, only 1. Now if we see from 60, is there any element just before 60 which is less than equal to 60? No. Here we found 80, so only 60 is less than equal to 60, that is 1. Now if we see from 70, if we see its previous elements, we can see that 60 is less than equal to 70, so we can count it. Then if we go back, 80 which is not less than equal to 70, so only we found is 60 which is less than equal to 70. So 60 and 70 will make 2, right? Only 2 elements which are less than equal to 70. Now if we see from the 60 which is less than equal to 60, sorry, so 70, we do not found anything which is less than equal to 60, so we stop here, because we need to find the consecutive number of stock prices which are less than equal to 60, and just before, it should be just before 60. So just before 60 there is a bigger element, so we do not found any element which is less than equal to 60, so itself would be less than equal to 60, so here only 1. Now see for 75, if we see 60 is less than equal to 75, then if we see 70 is less than equal to 75, then again we go back, 60 is also less than equal to 75. If we go back, 80, this is not less than equal to 75, so only 60, 70, 60, these are less than equal to 75. So these are 3 and it will include itself also, so total 4 elements which are less than equal to 75 just before 75, and these are consecutive, right? So if we see 85, let's see, 75, this is less than equal to 85, 80, 60, this is less than equal to 85, 70 less than equal to 85, 60 less than equal to 85, 80 less than equal to 85, 100, no, it is not. That's why 1, 2, 3, 4, 5 and itself 6. So this is the array we need to return. So in this algorithm, what we are doing, we're iterating through each and every element first, right? First we are iterating to 100, then 80, then 60, then 70, then 60, then 75, then 80. But for for each iteration, like for 70, we are going through its elements which are before 70, and 60 we are watching the elements which are before 60. For 75 we are iterating through the elements which are before 75. For 85 we are going through the elements which are before 85. So for every element we are seeing its previous elements. So in this case we are stopping at a point where we are getting the greater element. Like for 75, when we are stopping to iterate through its previous elements, 60, 70, 60, and when we are getting the element which is greater than the element, that's where we are stopping. Suppose if we would be having 1, 2, 3, 4, 5, 6, 7, then when we come at 2, we'll see it previous element 1, then 3, we'll get 2 is less than 3, 1 is less than 3, and throughout this array up to 7, I will iterate through every element, like 6 is less than 7, 5 is less than 7, 4 less than 7, 3, 2, 1. So for every element I am doing an iteration. Means for 2 I am doing one iteration. For 3 I am doing 2 iteration. For 4 I am doing 3 iteration. 5 4 iteration, 5 iteration, 6 iteration. So the total time complexity of this algorithm would be n square, because for every element I am doing n iterations, right? So its time complexity would be n square. We need to optimize this algorithm. So could there be a better solution than n square? Let's see. Let's observe something. For some element, like here 75, where we are stopping when we are getting the element which is greater than 75. Here we are stopping at 80. Means suppose if the indexes are 0, 1, 2, 3, 4, 5, and 6, and now if 75 would know that the greater element is residing on the position of 1, so suppose 75 knows this, then he could get the total elements which are less than equal to 75. How? Because 75 is standing at 5 and the greater element which is greater than 75 is standing at 1. So if he will do 5 minus 1, that is 4. So he would be getting these 4 elements which is less than or equal to 75. He did not needed to store these elements, means 60, 70, 60. He don't need this information. He just need the information that 80, which is greater than 75, is standing at which position, right? Suppose we do same for 85, which is the greater element, which is greater than 85, 100. Okay, so 100 is standing at which position? 0, right? So if 85 will calculate 6 minus 0, that is 6. You would get the elements 1, 2, 3, 4, 5, 6. These total 6 elements which are less than or equal to 85. So from this intuition, from this observation, what we get, that we just need the greater element than the current element and its index. Let's have a stack uh, which would store the greater element, right? Suppose we are having a stack, it would store the element and its position. Okay, so let's iterate through the array. 100. If the stack is empty, let's suppose that the previous index would be -1 if the stack is empty. Okay, so for 100, if we see in the stack is empty, so the previous position would be -1. So if we calculate the total number of elements, 0 minus 1, that is 1. So for 100 it would be 1. Okay, so we push 100 and its position 0 into the stack. Let's go to 80. If we see 80 can see that 100 which is greater than 80, so its position at 0. So 80's position is 1 and 100 position is 0. So the total number of elements are 1. So for 80, there are total 1 elements which are less than equal to 80 just before 80. Now we need to push 80 and 1 into the stack. 1 is its position, and now we see 60. 60, the greater element is 80. So its position is 1 and 60 position is 2. 2 minus 1, that is 1. So for 60, there are only one element which is less than equal to 60. For 70, so we will push 60 into the stack with its position, that is 2. Now if we see 70, for 70, 60 is not greater element, so just pop it out. Okay, and for popping it out, now after popping it out, I can see that 80 is the greater element. So 80 is at position 1 and 70 is at position 3. 3 minus 1, that is 2 elements. So total 2 elements which are less than equal to 70. So we are pushing 70 at position 3. Here you might be thinking that why we have popped out 60 from the stack. We popped out because if we see from this side, if 70 is the greater element for any element after 70, means 70 is greater element. So next previous greater element, then 60 cannot be previous greater element for any element which is after 70. Like for 60, 70 would be previous greater element. For 75, 80 would be greater element. Like for any element which is lesser than 70, which is occurring after 70, like 2. For 2, if 70 is the greater element, 60 would not be, right? That's why we are popping 60 out of it. We have pushed 70 with 3 position. Now again, if 60 sees its greater element is 70, so 4 minus 3, it is 1. For 60, that is 1. For 70, now I push 60 with position 4. Now I encountered 75, and if I see that 60 is not greater than 75, I pop it out. 70 is not greater than 75, I pop it out. 80 is greater than 75, right? So 80 is at position 1, so 75 is at position 5. 5 minus 1, that is 4, right? So 1 2 3 4, 4 elements for 75. And for 85, which is greater element? 80 is not greater element, pop it out. 100 is greater element, 100 is at which position? 0. So 6 minus 0, that is 6. So in this algorithm, we can see that in a single iteration, I can get these elements. Means these elements 1, 1, 2, 4, 1, 4, and for 85, that is 6. In a single iteration we are getting. So previously, the previous algorithm was taking n square of time complexity. Here we are doing the same thing in just time complexity of order of n, because we are doing just a single iteration. So let's just code it up. What do we need? A stack of pair of int and int, that is st, and an answer which we need to return, that is vector of int answer, right? So we will iterate through the array for int I is equal to 0, I less than a double r dot size I plus plus. First of all, what we would be doing, we would be popping out the elements which are less than or equal to the current element, right? So while stack is not empty, st dot while not st dot empty and a double r of I is greater than equal to st dot top dot first. Means at the first position we are storing the element, that's why what we would do is st dot pop, right? Now we need to get the previous index, which is greater than index at which the greater element is present. So int index would be, if stack would be empty, the index would be -1. So if st dot empty, if stack is empty, then what we do is the previous index would be -1, else it would be st dot top dot second, right? st dot top dot second, and now we will calculate the total number of elements, and elements would be index minus current index minus previous index. Let's call it previous index I minus previous index, right? So we will push it in answer dot push back elements, right? After pushing back the elements, let's push the current element and its position into the stack. st dot push current element is a double r of I and its position is I, right? And that's right. So we can return the answer. Let's see what happening. Elements previous index was not declared. Sorry, it is index, not indent. Here we are getting the right answer. Let's submit it up and see what's happening. And yeah, here we can see that it's the correct answer. So now let's see the time complexity. Here this for loop is taking order of n, right? And this while loop will take order of n throughout the program, right? And every other statement is order of 1, so the total time complexity would be 2n. Okay, that's it. Thank you so much.